The strategic geography of the Indo-Pacific theater imposes a ruthless tyranny of distance that renders traditional rotary-wing combat doctrine effectively obsolete against modern near-peer adversaries. Operating across the vast maritime expanses of the First Island chain requires projecting power over hundreds of miles, a demand that standard helicopter munitions cannot meet. The United States Marine Corps has recognized that relying on close air support platforms with single-digit engagement ranges is a calculated path toward total operational irrelevance. To alter this geometric disadvantage, the Corps initiated the Precision Attack Strike Munition program, or PASM, aimed at radically extending the lethal reach of its vertical lift. The centerpiece of this initiative is the Redwolf, a modular and low-cost munition developed by L3Harris that fundamentally redefines the engagement envelope of the AH-1Z Viper. Unlike traditional solid rocket motors that burn fast and die young, the Redwolf utilizes a miniature turbine engine to achieve sustained subsonic cruise for extended mission durations. This innovative propulsion architecture allows the munition to strike targets beyond 200 nautical miles, representing a range increase of nearly 4,000% over legacy systems. At a unit cost of approximately $300,000, the system represents an asymmetric economic lever capable of threatening high-value naval assets for minimal investment. The system is classified not merely as a missile, but as a launched effect, a nomenclature that signals a shift toward autonomous behavior and multi-mission modularity. By integrating this capability, the Marine Corps transforms the Viper from a tactical close-support gunship into a strategic node capable of over-the-horizon maritime interdiction and strike. The operational necessity for this shift drives from the Expeditionary Advanced Base Operations concept, which disperses small marine units across austere and contested island chains. In an EABO scenario, forward-deployed aviation assets must operate inside the adversary's weapons engagement zone without relying on the immediate availability of carrier-based fixed-wing air power. The Redwolf grants these dispersed units an organic deep strike capability, allowing them to punish enemy naval movements while remaining safely masked by terrain and ground clutter. This capability effectively decouples the launch platform from the target area, creating a survivability buffer that protects the aircrew from lethal medium-range integrated air defense systems. Current threat environments feature layered anti-access, area denial bubbles that make direct line-of-sight attacks by helicopters suicidal against modern corvettes or advanced guided missile destroyers. By pushing the launch point back 200 miles, the Viper can release its payload while remaining well outside the detection radius of sophisticated enemy shipborne radar systems. The Redwolf achieves this extreme range through high aspect ratio pop-out wings that generate significant lift, allowing it to glide and cruise rather than relying solely on thrust. This aerodynamic efficiency is critical for loitering operations, where the weapon can orbit a target area for up to 60 minutes before committing to a terminal attack. Loitering capability introduces a critical temporal dimension to the strike, enabling the weapon to wait for specific target behaviors or for validation from external offboard sensors. The distinction between a cruise missile and a suicide drone blurs here, offering commanders the flexibility to abort or redirect the weapon mid-flight as situations evolve. L3Harris has designed the vehicle to be platform agnostic, adhering to the Pentagon's weapons open system architecture to ensure seamless compatibility across the entire joint force. This modularity prevents vendor lock-in and ensures that the guidance software and payload packages can be upgraded independently of the physical airframe or the launch platform. The PASM requirements specifically mandate compatibility with the Universal Armament Interface, streamlining the integration process for future vertical takeoff and landing systems currently in development. The payload bay is designed to be swappable, accommodating kinetic warheads, electronic warfare jammers, or sensor packages depending on the specific profile of the mission. This versatility means a flight of Vipers could launch a mixed swarm, with some units acting as sensors and jammers while others deliver the final kinetic strike. The Greenwolf variant focuses on non-kinetic effects, potentially carrying jamming pods to blind enemy radar prior to the kinetic impact of the primary Redwolf strike package. Operating in a swarm configuration allows these munitions to overwhelm a ship's close-in weapon systems through sheer volume and synchronized time on target arrival from multiple vectors. The networking backbone of this system relies on Link 16 and MILST D6016 protocols, enabling the weapon to communicate with third-party assets like F-35S or naval destroyers. Network-enabled weapons do not require the launching helicopter to hold the target in its own sensors, breaking the traditional and vulnerable sensor-to-shooter linear kill chain. A forward-deployed drone or a satellite can provide the targeting data, while the helicopter acts merely as a mobile launch rail hidden safely behind an island landmass. This cooperative engagement capability is the defining feature of modern warfare, where the kill chain is distributed across a mesh network of disparate and autonomous platforms. The Redwolf's subsonic speed, while slower than supersonic anti-ship missiles, makes it harder to detect on Doppler radars that filter out slow-moving clutter like birds. Its small radar cross-section, combined with sea-skimming flight profiles, complicates the targeting solution for adversary point defense systems during the most critical phases of the flight. Comparison with the AGM-158 JAS-M reveals the Redwolf occupies a unique niche, high range but low cost and low weight, suitable for rotary-wing lift limits and requirements. The JAS-M offers a 500-mile range and a 1,000-pound warhead, but its size and weight preclude it from being carried by marine attack helicopters in relevant numbers. Conversely, the AGM-179J AGM offers precision and low collateral damage but forces the helicopter to close within 5 miles of the target, well inside the enemy's lethal range. The Redwolf effectively bridges this gap, offering a sufficient kinetic solution for targets like fast attack craft, landing ships, and mobile radar vehicles across the littoral environment. This tiered weaponology allows the Marine Corps to reserve expensive and heavy cruise missiles for hardened targets while using Redwolf for volume fire against distributed threats. The physics of the Pacific theater demand this volume. A conflict would likely involve hundreds of small maritime targets rather than a few massive and easily targeted battleships. L3Harris leverages hot swappable seeker heads, potentially allowing the missile to switch between imaging infrared, semi-active laser, or anti-radiation homing modes depending on the threat. Anti-radiation capability would allow the Redwolf to home in on enemy radar emissions, suppressing air defenses to clear the path for manned aircraft or follow-on missile strikes. The 200 nautical mile range also aligns with the logistical realities of the island hopping strategy, where fuel and rearmament points are scarce and widely separated across the ocean. By carrying long-range munitions, helicopters reduce their transit time and fuel burn, as they no longer need to fly all the way to the target for engagement. This standoff capability effectively extends the combat radius of the AH-1Z Viper, mitigating its inherent fuel limitations compared to more efficient fixed-wing assets in the theater. The Launched Effects designation also implies a future roadmap where these vehicles could deploy sub-munitions or act as persistent communication relays for dispersed ground forces. A Redwolf configured as a relay could loft a radio repeater to high altitude, temporarily bridging communication gaps between separated marine units in a satellite-denied environment. This multi-domain utility justifies the unit cost, as the system replaces the need for dedicated specialized platforms in high-risk environments while maintaining a small logistical footprint. The integration of Redwolf forces a rethinking of the scout weapon team concept, evolving it into a network strike manager role for the modern attack helicopter pilot. Pilots will no longer just fly and shoot. They will manage a constellation of semi-autonomous assets, authorizing strikes based on data streams from the global network. This cognitive shift requires new training pipelines and user interfaces, as the complexity of managing a swarm exceeds the workload of traditional line-of-sight targeting methods. Extending the engagement ring to 200 nautical miles introduces a severe geometric complication. The curvature of the Earth aggressively limits the launching platform's line of sight. A Viper helicopter hovering at 2,000 feet has a radar horizon of approximately 55 miles, leaving a blind spot of nearly 150 miles. This physics constraint means the Redwolf must fly the majority of its trajectory based on data provided by external sources, not the helicopter's own sensors. The kill chain, the sequence of finding, fixing, tracking, and engaging mutates from a single platform loop into a distributed network architecture spanning the entire theater. Target coordinates are likely generated by high-altitude assets like the MQ-4C Triton, space-based synthetic aperture radar, or F-35S, operating deep inside the threat envelope. The launching helicopter effectively becomes a bomb truck, a kinetic delivery node that services targets it will never physically see with its own eyes. Once the weapon is airborne, the Wolfpack concept activates, leveraging the collaborative autonomy of multiple munitions networking together in flight to optimize the attack. This brings us to the Greenwolf, the non-kinetic twin in the family, designed not to explode, but to confuse, blind, and disrupt enemy sensors. A typical strike package might consist of 2 Greenwolves leading a flight of 4 Redwolves, forming a composite screen against enemy air defense networks. The Greenwolf carries an electronic warfare payload capable of detect, identify, locate, and report missions, sniffing out enemy radar emissions in real time. Upon detecting a threat radar, the Greenwolf can shift modes to EW disrupt, jamming the specific frequency band to create a safe corridor for the trailing Redwolves. This hunter-killer symbiosis allows the swarm to penetrate layered air defense bubbles that would easily swat down a single, non-stealthy subsonic missile. The Greenwolf can also act as a decoy, mimicking the radar cross-section of a larger aircraft or ship to seduce enemy fire away from the real shooters. This expendable mass strategy forces the adversary to waste expensive interceptors, often costing millions against a $300,000 drone, imposing a favorable cost-exchange ratio. The sheer volume of incoming targets saturates the fire control channels of enemy destroyers, exploiting the raid count limit inherent in any Aegis-class combat system. L3Harris has integrated tablet-based control interfaces for these systems, allowing aircrew to manage the swarm's behavior with point-and-click simplicity rather than complex coding. Mid-course updates are transmitted via Link 16, allowing the swarm to dynamically reroute if the target situation changes or if new threats suddenly appear. However, the terminal phase remains the most technically demanding segment of the flight profile, particularly against moving maritime targets in high-sea states. A ship traveling at 30 knots will move approximately 35 miles during the Redwolf's hour-long flight time, creating a massive uncertainty volume for the seeker. To solve this, the Redwolf must activate its own organic seekers, likely a multi-mode mix of imaging infrared and semi-active laser to reacquire the target. This autonomy in the endgame is critical because jamming or network denial might sever the link to human operators just as the missile begins its dive. Unlike the Hellfire, which requires continuous laser designation or short-range radar lock, the Redwolf is designed for fire-and-forget operations in degraded electromagnetic environments. The tactical implication for the Marine Corps is a shift from close air support to deep air interdiction, a role traditionally jealously guarded by fixed-wing aviation. This capability allows a pair of Vipers to shut down a strait or harass enemy logistics convoys without ever exposing themselves to the lethal envelope of shipborne missiles. The PASM program effectively resurrects the operational utility of the attack helicopter in high-intensity conflict, saving it from total strategic obsolescence. Without this range extension, the AH-1Z would be relegated to rear area security, unable to contribute meaningfully to the primary naval fight in the Pacific. Comparison with the Naval Strike Missile highlights the specific niche Redwolf occupies. The NSM is a 900-pound weapon requiring a heavy truck or ship to launch. The Redwolf, at roughly 250 pounds, fits on the wing pylons of a helicopter, granting mobility and vertical terrain access that heavy batteries lack. Marines can land a Viper on a remote beach, refuel from bladders, launch a strike, and relocate before enemy counter-battery fire can triangulate their position. This aligns perfectly with the stand-in force's concept: small, mobile, lethal units operating inside the enemy's weapons engagement zone but remaining hard to kill. The launched effect classification also suggests future compatibility with other platforms, such as the KC-130J Harvest Hawk or even ground-based launchers. L3Harris documents explicitly mention compatibility with Group 3 UAS, implying that large drones could eventually serve as motherships for these missiles. This creates a tiered arsenal where a single C-130 could deploy a wolf pack of 20-plus munitions, instantly creating a mass strike event from a cargo plane. The modular weapons open system architecture ensures that as enemy jamming improves, the Marines can swap out the seeker head without buying a whole new missile. This software-defined approach contrasts sharply with legacy weapons like the Harpoon, which required costly block upgrades to improve performance or address obsolescence. The subsonic speed of Redwolf is a trade-off. It lacks the kinetic punch of a supersonic impact, but gains significant range and fuel efficiency. To compensate for the lack of speed, the system relies on low-altitude sea-skimming flight profiles to hide within the radar clutter of the waves. By flying 10 to 20 feet above the water, the missile remains below the horizon of ship radar until it is less than 20 miles away. At that range, the ship's defenses have less than 2 minutes to react, identify the threat, and generate a firing solution before impact. When simultaneous arrival is timed correctly, a swarm of Red Wolves can overwhelm the fire control channels of a Corvette-sized vessel through saturation. The integration of these systems into the fleet is scheduled for fiscal year 2027, a rapid timeline that underscores the urgency of the Indo-Pacific threat. This speed to fleet is facilitated by the use of other transaction authority contracts, which bypass the sclerotic traditional acquisition bureaucracy of the Pentagon. The cost per shot analysis is brutal but necessary. Trading a $300,000 missile for a $5 million enemy patrol boat is a sustainable economic model. Conversely, firing a $2 million Tomahawk at that same patrol boat is a strategic failure, depleting critical stocks of high-end weapons on low-end targets. Redwolf fills the affordable mass gap, preserving high-end inventory for aircraft carriers and hardened bunkers that require heavier warheads. The operational concept also anticipates a tritable usage, where commanders can accept the loss of several missiles to gain intel or force the enemy to unmask. A Greenwolf that gets shot down after forcing a hostile SAM site to light up has successfully completed its mission by revealing the enemy's location. This tactical baiting transforms the munition from a simple weapon into a reconnaissance by fire asset that shapes the battlefield for follow-on strikes. The future of marine aviation lies not in better flight performance of the helicopters, but in the intelligence and range of the things they launch. The Viper is no longer the weapon, it is merely the first stage of the propulsion system for the actual weapon, the Wolf Pack. Integrating a 200 nautical mile weapon onto a rotary-wing platform requires a fundamental redesign of the aircraft's mission computer and storm management system. The AH-1Z Viper was originally wired to speak the language of Hellfire missiles, short digital bursts confirming laser codes, and simple lock-on status. Redwolf demands a far more complex dialogue, requiring the rapid transfer of waypoints, threat libraries, and localized rules of engagement before release. This necessitates the Universal Armament Interface, a software middleware that allows the helicopter to recognize and control the munition without a complete operational flight program rewrite. Without UAI, every new missile variant would require a years-long recertification process for the aircraft's core software, a timeline the Marine Corps cannot afford. The physical footprint of the Redwolf also imposes constraints. While lighter than a cruise missile, its length and weight affect the helicopter's center of gravity. A fully loaded Viper carrying 4 Redwolves and 2 auxiliary fuel tanks faces significant performance penalties in hot and high conditions typical of tropical environments. However, the trade-off is calculated. The helicopter accepts reduced agility in exchange for the ability to strike without ever entering the enemy's engagement zone. The concept of launched effects transcends the traditional definition of a missile, moving into the realm of deployable off-board sensing and remote action. In this architecture, the helicopter is no longer just a shooter. It is a mothership deploying a localized constellation of sensors and effectors. The terminology reflects a shift in doctrine. Effects implies that kinetic destruction is just one option on a menu that includes jamming, decoys, and surveillance. This aligns with the kill web theory, where every node in the battle space can contribute to the targeting solution for any other node. The Redwolf's modular payload bay is central to this, allowing forward-deployed maintenance crews to swap mission packages based on daily intelligence reports. If the day's mission involves suppressing an enemy radar site, the munitions are fitted with anti-radiation seekers and specialized electronic warfare payloads. If the mission shifts to interdicting a convoy of landing craft, the payload swaps to a semi-armor-piercing warhead with a terminal infrared seeker. This logistical flexibility reduces the Iron Mountain of specialized munitions that must be shipped to forward bases, streamlining the vulnerable supply chain. The Greenwolf electronic warfare variant addresses a critical vulnerability of subsonic cruise weapons, their susceptibility to interception by modern air defenses. By flying alongside the kinetic variants, Greenwolf provides a portable electronic countermeasures bubble, jamming the fire control radars of enemy ships. This escort jamming capability was previously the exclusive domain of specialized aircraft like the EA-18G Growler, which are scarce and high-demand assets. Downscaling this capability into an expendable missile airframe democratizes electronic warfare, putting it directly in the hands of the tactical commander. The network architecture relies heavily on Link 16, the standard tactical data link for NATO and allied forces, ensuring broad interoperability. However, Link 16 is a high-emission, line-of-sight waveform that is susceptible to detection and jamming by sophisticated peer adversaries. To mitigate this, Redwolf likely incorporates low probability of intercept and low probability of detection communications for its internal swarm network. These covert waveforms allow the Wolf Pack to coordinate their attack timing and geometry without alerting the enemy's electronic support measures. Navigating 200 miles in a GPS-denied environment, a certainty in a conflict with a near peer, requires robust backup navigation systems. The Redwolf utilizes a military-grade inertial navigation system coupled with likely terrain contour matching or visual odometry to maintain course when GPS is jammed. Visual odometry uses downward-facing cameras to track the terrain passing below, comparing it to an onboard map to correct inertial drift. This allows the weapon to navigate blind through the mid-course phase, only activating its primary seeker in the final seconds of the attack. The combination of INS and optical navigation makes the system resilient against the massive GPS spoofing expected in the Taiwan Strait. Comparison with the Israeli Spike and LOS reveals the scale of the Marine Corps' ambition. Spike hits out to 32 kilometers. Redwolf aims for 370. While Spike offers a man-in-the-loop fiber optic link for extreme precision, its range is insufficient for the vast distances of the first island chain. Redwolf sacrifices the continuous video feed of a fiber optic link for the sheer reach required to span the gaps between islands. This range capability puts the Redwolf in a unique class, bridging the gap between tactical anti-tank missiles and strategic land attack cruise missiles. It effectively creates a middleweight class of munitions, optimized for the operational constraints of the Marine Littoral Regiment. The unit cost of $300,000 is achieved by leveraging commercial off-the-shelf components and advanced manufacturing techniques. Additive manufacturing allows complex internal geometries for fuel tanks and cooling channels to be printed in a single piece, reducing parts count. This manufacturing speed is a strategic asset, allowing the industrial base to surge production rapidly in the event of a prolonged conflict. Traditional missile production lines can take months to assemble a single weapon. The Redwolf aims for a production cadence closer to consumer drones. The low cost also changes the psychological calculus of the commander, encouraging the use of weapons against targets of opportunity. Commanders are often hesitant to authorize a $1.5 million Tomahawk strike on a suspected target. A cheaper Redwolf lowers that threshold. This permission-to-fire dynamic increases the tempo of operations, allowing Marines to engage fleeting targets before they disappear. The 200 nautical mile range also opens up cross-domain firing solutions, where a ground-based launcher on one island can support a naval engagement. While the primary focus is aviation, the launched effect nature of Redwolf means it is inherently launch platform agnostic. The Marines are actively exploring the Roguefire's vehicle, a driverless JLTV chassis, as a potential ground launcher for the Redwolf family. This would give ground units the same over-the-horizon punch as the aviation combat element, further distributing lethality across the force. A dispersed network of ground launchers and helicopters creates a complex dilemma for the enemy, who cannot predict where the next strike will originate. The enemy must scan the sky, the sea, and the islands simultaneously, diluting their sensor resources and processing power. This saturation effect is the core tenet of distributed maritime operations, preventing the adversary from concentrating their defenses on a single axis. The Redwolf is the kinetic enabler of this doctrine, providing the physical means to execute the theoretical concepts of modern maneuver warfare. It transforms the empty ocean from a barrier into a maneuver space, where distance is weaponized against an enemy relying on centralized fleets. The geometric reality of a 200 nautical mile shot creates a sensor-shooter disconnect that defines the modern distributed kill chain. A Viper pilot launching a Redwolf at extreme range is effectively firing blind, relying entirely on a digital target track provided by an external asset. The F-35 Lightning II becomes the critical enabler here, using its advanced sensor suite to penetrate high-threat areas and relay target coordinates. This manned-unmanned teaming transforms the F-35 into a forward observer and the Viper into a mobile standoff artillery battery. The F-35 detects the enemy fleet using its passive sensors, avoiding radar detection, and squirts a burst transmission over Link 16 to the loitering Vipers. The Vipers, hovering safely behind terrain masking, ripple-fire their Redwolves and immediately displace to a new firing position to avoid counter-battery fire. This shoot-and-scoot tactic is vital because the launch signature of a turbine-powered missile is significant enough to be detected by space-based infrared sensors. Once airborne, the Redwolf flies a complex, non-linear flight path to confuse enemy air defense computers trying to calculate the launch point. Waypoint navigation allows the missile to approach the target from a different quadrant than the launch, creating a false axis of attack. This deception capability forces the enemy to defend a 360-degree perimeter, diluting their defensive firepower across all sectors. Against moving targets like frigates or destroyers, the missile receives mid-course updates to refine the target's predicted location in real time. However, in a link-severed environment where enemy jamming cuts off communication, the Redwolf must rely on its own terminal seeker to find the ship. The seeker likely employs a library of ship silhouettes, comparing the radar or infrared image it sees against a database of known enemy vessels. This automatic target recognition prevents the missile from wasting itself on a civilian freighter or a decoy barge deployed to confuse the sensor. The logistics of the Redwolf are equally transformative. Its small footprint allows it to be transported in significant numbers by MV-22 Ospreys. A standard cargo pallet can hold multiple Redwolf rounds, whereas a single JASSM or NSM takes up nearly the entire cargo volume of a tactical transport. This magazine depth is critical for the Expeditionary Advanced Base Operations concept, where resupply is difficult and infrequent. Marines on a remote island can stockpile dozens of Redwolves, creating a persistent denial-of-sea capability that doesn't require a runway or a port. The cost savings also extend to training. Pilots can simulate Redwolf launches in the simulator, but the low unit cost allows for occasional live-fire exercises. Live-fire validation is essential to build trust in the system, proving to the aircrew that the weapon will actually go where it is pointed. The transition to launched effects also implies a future where the weapon itself becomes a sensor platform, beaming data back before it impacts. A Redwolf could fly a reconnaissance pattern over a target area, transmit bomb damage assessment images, and then strike a surviving target. This sensor-then-shooter capability compresses the OODA loop: observe, orient, decide, act, allowing for rapid re-engagement of surviving enemy forces. The integration of Redwolf also addresses the Marine Corps' capability gap in long-range precision fires, a vulnerability identified in numerous war games. Previous simulations showed Marine helicopters being pushed out of the fight by long-range surface-to-air missiles. Redwolf brings them back into the game. It forces the enemy to respect the threat ring of every Marine helicopter, complicating their operational planning and restricting their freedom of maneuver. The Redwolf's subsonic speed is a calculated vulnerability, but one mitigated by its low altitude and small radar cross-section. Flying at Mach 0.7 at 20 feet above the waves makes detection difficult for ship radars until the missile breaks the radar horizon at roughly 15 miles. At that range, a ship traveling at 30 knots has less than 90 seconds to detect, track, classify, and engage the incoming threat. If the attack is synchronized with multiple missiles arriving simultaneously from different azimuths, the ship's defensive system is mathematically overwhelmed. This saturation attack logic is the core of modern anti-ship warfare, relying on volume rather than the invincibility of a single missile. The Greenwolf EW variant plays a pivotal role here, acting as a force multiplier by degrading the enemy's detection range. By jamming the enemy's search radar, Greenwolf reduces the effective detection range, buying the kinetic Redwolves precious seconds to close the distance. This electronic screen allows subsonic missiles to penetrate defenses that were designed to stop supersonic threats. The modularity of the system also allows for rapid adaptation to new enemy countermeasures as they emerge in the theater. If the enemy introduces a new radar frequency, software engineers can update the Greenwolf's jamming library and push the patch to the fleet in days. This agile software development model is a radical departure from the hardware-centric upgrades of the past. The Marine Corps is effectively buying an iPhone-like platform where the apps, payloads, and software matter more than the phone itself. Redwolf essentially acts as a flying server rack, capable of hosting whatever software or hardware mission module is required. This aligns with the Commandant's planning guidance, which calls for reconnaissance and counter-reconnaissance capabilities at every echelon. While the Army's Precision Strike Missile handles the deep ballistic trajectory fight, Redwolf handles the tactical, air-breathing fight. They are complementary systems, not competitors, covering different altitude and range bands to present a multi-dimensional threat. The cheapest price tag of $300,000 is still significant, but compared to the $100 million aircraft it protects, it is an expendable insurance policy. Losing a Redwolf to enemy fire is a tactical inconvenience. Losing a Viper and its crew is a strategic loss. This loss tolerance is central to the design philosophy, encouraging aggressive use in contested airspace. The Redwolf program is also a litmus test for the Pentagon's ability to adopt commercial technology at speed. Leveraging L3Harris's commercial supply chain for components like actuators and sensors reduces reliance on specialized military-grade parts. This commercial derivative approach is essential for scaling production to meet the demands of a high-intensity conflict. The ultimate goal is a magazine depth that allows Marine commanders to fire freely without constantly checking their inventory levels. Logistics in the Pacific is not a support function. It is the primary constraint on operational reach and tempo. Moving heavy ordnance like 2,000-pound bombs or Harpoon missiles to dispersed island bases requires massive lift capacity that will be targeted by enemy long-range fires. The Redwolf's compact form factor allows it to be transported by smaller connectors like the CH-53K King Stallion or even autonomous surface vessels. A single CH-53K can deliver a magazine in a box, a preloaded container of 20 Redwolves to a forward arming and refueling point in a contested zone. This capability decouples the ammunition supply from the vulnerable large-deck amphibious ships, creating a distributed web of supply nodes that is harder to interdict. The operational concept forces the adversary to widen their surveillance aperture, scanning thousands of small islands for potential missile caches, rather than just watching known air bases. This shell game of logistics complicates the enemy's targeting cycle, forcing them to expend high-value ISR assets on low-value geography. Once launched, the Redwolf enters the most critical phase of its flight, the mid-course navigation through a contested electronic spectrum. In a high-intensity conflict, the GPS signal will likely be jammed or spoofed by high-power terrestrial jammers, rendering standard satellite navigation useless. The Redwolf anticipates this by incorporating an anti-jam GPS antenna and a robust inertial measurement unit that can coast through jamming spikes. For extended GPS denial, the system likely integrates a visual navigation backup, comparing terrain features against an onboard digital map to correct its course. This absolute navigation capability ensures that even if the satellite constellation goes dark, the missile knows where it is relative to the target. The terminal phase introduces the challenge of target discrimination, picking the correct ship out of a formation or a cluttered commercial shipping lane. Advanced image processing algorithms on the seeker head analyze the target's geometry, thermal signature, and radar return to classify it before impact. This cognitive sensing reduces the risk of collateral damage and ensures the weapon hits the high-value combatant, not a decoy. The Redwolf's modularity also allows for rapid reprogramming of these target libraries based on new intelligence about enemy ship modifications. If the enemy starts welding radar reflectors onto their decks to confuse seekers, the software can be updated to recognize and ignore those specific countermeasures. This constant cat-and-mouse game of measure and countermeasure is fought in code long before the first missile is fired. The inclusion of the Greenwolf variant effectively creates a localized SEAD capability for the helicopter flight. A Greenwolf, equipped with a radar jammer, can blind the fire control radar of a destroyer, allowing the kinetic Redwolves to penetrate the final defensive layer. This escort jamming tactic was previously impossible for helicopters, which lacked the power generation to run heavy jamming pods. By offloading the jamming mission to an expendable missile, the helicopter retains its power for flight and communications while still projecting electronic effects. The PASM program effectively blurs the line between a munition and a drone, creating a hybrid category of smart weapons that act like wingmen. This doctrinal shift is mirrored in the Air Force's Golden Horde initiative, which seeks to network small-diameter bombs into collaborative swarms. The Marine Corps is applying this same logic to the literal fight, prioritizing autonomy and collaboration over raw speed or warhead size. The swarm behavior allows the weapons to share target data in flight. If one missile is shot down, it can transmit the location of the threat to the surviving missiles. The survivors can then dynamically reroute to avoid the air defense site or coordinate a simultaneous convergence on the threat emitter. This self-healing network makes the volley resilient, ensuring that even with high attrition, some percentage of the strike package reaches the target. The Redwolf also offers a loiter and hunt mode, where it can orbit a suspected target area for up to an hour, waiting for a vehicle to break cover. This persistence is invaluable for hunting mobile missile launchers or command vehicles that utilize shoot-and-scoot tactics. Instead of guessing where the enemy will be, the Redwolf hangs in the air, watching with its sensors until the target reveals itself. The ability to abort an attack is equally critical. If a civilian enters the blast radius, the operator can command the missile to splash safely in the ocean. This man-in-the-loop capability is a legal and ethical necessity for operations in congested environments where civilians are present. The 200 nautical mile range effectively doubles the combat radius of the AH-1Z Viper without requiring a single drop of extra fuel. It transforms the helicopter from a tactical asset tethered to the forward edge of the battle area into a strategic asset capable of deep interdiction. This range extension is the only way to keep the attack helicopter relevant in an era of hypersonic missiles and 400-mile air defense systems. Critics argue that subsonic missiles are too easy to intercept, but this ignores the cost imposition strategy. Forcing the enemy to fire a $2 million SM-6 or similar interceptor to kill a $300,000 Redwolf is a tactical loss but a strategic victory. Depleting the enemy's limited stock of high-end interceptors exposes their high-value ships to follow-on attacks by heavy anti-ship missiles. The Redwolf acts as a magazine drain, soaking up defensive fires to pave the way for more lethal strikes. This layered offense uses cheap, numerous weapons to strip the enemy's shields before the heavy hitters like the Naval Strike Missile arrive. The integration of Redwolf into the marine aviation ecosystem is also a cultural challenge, requiring pilots to trust autonomous systems. Trust is built through transparency. The weapon's interface must clearly communicate its intent and status to the pilot before launch. Human-machine teaming is not just a buzzword. It is the operational standard for 21st century warfare, demanding new interfaces and training. The pilot becomes a mission commander, overseeing a robotic loyal wingman rather than just pulling a trigger. As the Marine Corps pushes towards Force Design 2030, systems like PASM and Redwolf are the tangible hardware of that vision. They represent a shift from heavy metal maneuver to distributed lethality, trading armor and mass for range and intelligence. The Redwolf is the physical manifestation of the Corps' intent to fight inside the enemy's weapons engagement zone and win. It is a small war weapon designed for a big war problem, proving that size is not the only determinant of lethality. In the final analysis, the Redwolf gives the Marine on the ground or in the air a stick long enough to poke the bear without getting bitten. The operational independence gained by the Marine Corps through PASM cannot be overstated. It reduces the request to fire latency that plagues joint operations. However, the reliance on such complex kill chains introduces a new fragility. The bandwidth requirements for controlling swarms in a jammed environment are immense. While Link 16 is robust, it is not infinite. Managing dozens of missiles, each streaming telemetry and seeker video, could saturate the local tactical network. To solve this, L3Harris is likely investigating edge processing, where the missile processes data internally and only transmits simple text-based status updates. This reduces the data load from megabytes of streaming video to mere kilobytes of text, preserving the network for critical command signals. The ultimate vision is a collaborative autonomy where the missiles talk to each other more than they talk to the pilot. If one missile detects a new threat, it automatically cues the others to adjust their flight paths, executing a complex pincer maneuver without human intervention. This level of autonomy raises doctrinal and ethical questions, but the speed of machine-on-machine warfare likely renders human decision-making too slow for the terminal phase. The man in the loop will effectively become a man on the loop, monitoring the swarm's execution rather than micromanaging individual flight controls. As the U.S. military pivots to the Pacific, the success of PASM will determine whether the attack helicopter remains a predator or becomes prey. The Redwolf buys the AH-1Z Viper a new lease on life, evolving it from a tank killer into a maritime strike node. It is a recognition that in modern war, range is the primary determinant of survivability. The 200 nautical mile metric is not just a number, it is the difference between launching from sanctuary and launching from a grave. Future iterations of the system will likely incorporate solid-state batteries or hybrid propulsion to further reduce acoustic and thermal signatures. We can also anticipate the integration of loitering sensors that detach from the main missile body to provide persistent surveillance after the strike. This would allow a commander to verify the kill instantly, closing the feedback loop required for re-attack decisions. The cheapish nature of the weapon also invites experimentation. Marines are notorious for jury-rigging systems to work in ways engineers never intended. Expect to see field-expedient launchers mounted on unplanned vehicles or software hacks that allow the missile to target specific electronic emitters. This adaptability is the core strength of the Marine Corps, and the open architecture of PASM is designed to harness it. The Redwolf is not a silver bullet, but it is a necessary evolution, shifting the cost curve back in favor of the offense. It acknowledges that fighting China requires volume, and volume requires affordability. As we observe the continued rollout of Force Design 2030, the integration of these systems will be the primary metric of success. The transition from legacy platforms to intelligent munitions is painful but essential for a 21st century fighting force. To validate these concepts, our team will be deploying to Camp Lejeune this April to document the Marine drone attack competition. We will be analyzing how the Corps is integrating first-person view drones and other expendable munitions at the squad level. This coverage will provide a ground truth assessment of whether the innovation discussed in the Pentagon is actually reaching the Lance Corporals in the field. The gap between PowerPoint doctrine and mud and blood reality is often wide. We intend to measure it. Expect detailed breakdowns on the tactical employment of these systems, specifically how they interface with the larger kill web we've discussed today. We will interview the operators, the NCOs, and junior enlisted who are tasked with making these complex systems work in austere conditions. Their feedback is the only data point that truly matters when assessing combat readiness. If you have specific technical questions regarding the PASM architecture or drone integration you want answered during our field investigation, direct them to the secure channel. We filter through significant volumes of correspondence, so precise, technical inquiries are prioritized over general commentary. For those supporting the channel's independent analysis, the logistics link is active. Proceeds directly fund field deployments like the Lejeune operation. The acquisition of high-fidelity intelligence requires resources. Your support ensures we remain operational and independent of defense industry sponsorship. The Redwolf is just one component of a massive systematic overhaul. It represents the Marine Corps' gamble that smaller, smarter, and more numerous is better than bigger, faster, and fewer. Whether this gamble pays off will be decided not in a boardroom, but across the vast distances of the Philippine Sea. Until then, the focus remains on the physics of the kill chain. Detect, track, launch, destroy. Anything else is just marketing. We will continue to track the development of the Launched Effects family as L3Harris moves from prototype to production. Watch for the upcoming critical design review and the initial operational capability declaration in late 2026. This is the new baseline for rotary-wing warfare. The era of the gun run is ending. The era of the network strike has begun. Stay critical. Stay informed. This is Task and Purpose.